Okay, this video will be covering the quantity takeoff, how to do the quantity takeoff, and how it differs from certain stages from PSQ, preliminary quantities, then DSQ, detailed, and then the ESQ, which is the execution. So we will explain here what should be the differences and how we can utilize the use of the quantity takeoff templates. For this video, we will be using the shear wall, quantity takeoff or shear wall as example, since shear wall is the one of the most complicated items to estimate, especially when converting it to precast. Okay, so let's go back to the standard folder. Inside the standard folder for this type, it's PSQ. Then quantity takeoff is under in PSQ folder. Then let's go to quantity takeoff. Let's familiarize first ourselves from the template. All of our templates is structured like this. Okay, so we have the procedure, how we will do the estimate. Okay, we review the framing plan, establish wall heights, input wall schedule. So basically, the first 1 to 3 is the geometry. Then the item 4 will be the generation of ratio. So we have different level of information and then different level of accuracy expected on each of the stages of the quantity. So meaning that we don't expect that PSQ, DSQ, and ESQ will have the same quantity, but ideally it should have to minimize the repetitiveness. Okay, but as we all know, during in each stage, there are different level of information present, so we should base our judgment on the provided level of information. Okay, then do the quantity CIP, PC, CIP, then generate cost comparison. Okay, so this is the template for the inputs. Okay, so what are the important items? As I mentioned earlier in the procedure, we should study the framing plan, schedule, designer, and shear wall detail. Okay, then we will generate this concrete and formworks template. So the first part, this is the shear wall mark or the name of the shear wall. So we have shear wall 1, shear wall 2, shear wall 3. Then we have the number of floors of each shear wall. So then we have this blue will represent the total quantity for each shear wall. So something like this. Okay. Then we have the number of set. How many shear wall 1 do we have? Then the thickness of shear wall 1 for the specific shear wall. Then the length, which will be the based on the framing plan. Then we have height or the floor-to-floor height. Then slab thickness. So this is very important when we're converting into precast. And then definitely the mortar thickness. So for the mortar thickness, we're using 20 mm always. It's constant for everything because the main purpose of the mortar thickness is for the leveling of the precast. Okay, when we already use the precast shear walls. Okay, then we have a rebar tab. Basically, this rebar tab is editable. Okay, meaning it depends on the level of information present. Okay, so later we will go back for the rebar tab. So we just go first to the concrete and formworks. So concrete is just basically the volume. Then we have cast in place area or the CIP area, which is the formworks. If we will do it in cast in place, okay? Then definitely the rebar, as mentioned, we will just go back now. So this column J to L represents the standard quantity or the CIP quantity. So this is something that everybody is already familiar because basically concrete is volume and CIP area is basically surface area. So these two things were very easy. Okay, so it can be easily formulated, and it is highly dependent on the inputs of the estimator. Okay, so the most likely that the error that will occur here is only the database input. Okay, so the estimator should know or should see or should be very accurate on this one. And using this one, we are assured that the concrete and formworks quantity will be around 95 to 100% accurate, because this is all based on the plans. Okay, it is already given the plan, so there might be minimal changes along the way. Okay, so then there is a method. In this method, we need basically to define if it is cast in place or precast. Okay, so for example, for shear wall 1, shear wall 1 might be cast in place in ground floor up to fifth floor, and then it can be precast from 6th floor to 10th floor. So this should define what will be the method to be used in the precast. And in relation to this, the quantities will change. So for the composition of CIP plus precast, so we call this pure CIP as the conventional. Then this is the combination, the composite part, the CIP and the precast. For the precast and CIP, it should have these parts. We have the mortar part. We have the concrete, which will be the remaining cast in place concrete. We have the CIP area, which will be the remaining cast in place area, or the remaining formwork. And then we have the precast quantity here in square meter, and we have shoring quantity. Okay, so as you can see, if the methodology is CIP, then the quantity will just be equal to the conventional. If it is precast, then it's composition of the items. Okay, to check the result, so it should be that the remaining volume should be equal to the mortar quantity plus concrete quantity plus precast volume. In this case, precast is square meter, then we need to multiply it by its thickness, which is 0.175. Okay, so what happened? Then, let's double check. It's wrong. Should be R15. Okay, times 0.175. Okay, so as you can see, the total volume will be equal. Okay, so I prepared to follow exactly the template, the format. So there should be a header and there should be a total. This blue line will represent the total, so they have the same mark. So it should be in formula like that for easier checking and tracking of information. Okay, so that's for the concrete form mix. So definitely, assuming everything, all of the inputs that the estimator did is correct, then the quantity here and the quantity here, all the quantity that we'll be getting regarding concrete form mix and precast quantity is 95 to 100% accurate. Okay, so let's go to the rebar, which is the by the way, in this part, in computing the concrete formworks, there's no difference if you will do it in during PSQ, DSQ, or ESQ, or basically it doesn't, the procedure will be the same. Now, there's no changes. If there will be no changes in the geometry of the structure, then you don't have to redo everything. So that's why it's very important that prior to doing this, we already have our detailed design review checklist, or we already did our plan review. So in plan review, you can already define which structure is changing. So it can minimize the time you're consuming in doing your job or work, especially when you're doing the DSQ translating to ESQ, because it's most of the time it's just the same. Most of the time, it's the level of the information of rebar. It's changing. It's not the concrete or the geometry of the structures. So we need to spend time in reviewing, because it might increase you around 1 hour. It might increase you 1 hour. It may consume 1 hour, one hour of your time doing the estimate, but it can save you more than 50% of the time. In case of the you can optimize the time more than 50%, especially if the sizes will just be the same. Okay, if the geometry didn't change. Basically, if the geometry didn't change. Okay, now we go to the quantity takeoff. In the quantity takeoff, we have this one, for example. So this sample for this is shear wall 1. So assuming we use shear wall 1, and let's check how many floors. 10 floors. So let's complete it. Okay, so assuming this is the main bars. So just we can put there the main bars. We can put here the thickness. Let's check the thickness. 175. I suggest to put here the thickness, just for reference. Then this is the main bar. Top is MB. Then everything is traceable. Okay, so we can put here total shear wall 1. Okay, to define it again, so I suggest to use fill of yellow for the tagging, and then fill of black. So fill of black for the reverse, for the total of the specific shear wall. Okay, this is the main bar. Then you might have another tab or another quantity that might be the ties. Okay, so we're gonna change the quantity, ties and horizontal bars. Horizontal bars. I will not change the quantity since it's the same time. Okay, but basically, if you have this scenario, I highly suggest that to make it in one, because at the end we need the quantity per structure. Okay, so we can remove this one, and then just the total. So that way, we already have the total quantity for shear wall, main bar, and ties. So I suggest it to be like this. It's more useful if you will do it like this. Okay, and then this portion, as I mentioned, during based on the level of information changes or varies depending on the quantity that we are producing. For example, if it is a PSQ, then we are expecting only one quantity takeoff. Okay, so you will just need one, which we considered as the critical. So we say this is critical. The important thing is that it covers all the floors. Or I mean, the definition of critical, in defining the critical structure for shear wall, it will be based on your engineering judgment and experience. So on this part, we highly need the estimator to have the experience. No? Basically, more of design, because the designer would know, or the one who decided it would know which will be the most critical structure. Okay, so if you're not yet familiar, you can do more. You can consider more structure, but considering the timeline that we have, it is better to just consider the most critical one. Okay, so for this case, we consider it the shear wall 1. No, okay. Then we will generate the ratio reference. So if this is shear wall 1, let's check how many shear wall 1 are there. There are 2 shear wall 1s. Shear wall 1. So let's just put it 2. Okay. Then we need the floor to floor. Okay. We need the quantity per floor. So just copy this one. And then this one. The total. Okay. So always make it like that. So this will be the quantity per floor. Okay. So how to deal with how to get the quantity per floor? So just delete everything. You don't need this one. You don't need this one. Okay. So this one. So we just need to make sure that so for this one we just tell it a shear wall one, but we don't necessarily we can make it as the total shear wall total as general. So shear wall total it's general, meaning if you have any shear wall, so at the end of the day we need to get the per floor quantity. Okay, so we can delete all of this. And then change this formula. Make sure to edit all the formula so we are consistent. Okay, then we just need to do the sum ifs. Okay, so I hope everybody is familiar regarding sum ifs. So some criteria or sum range is the first part. So this just need to highlight basically the whole database that you need to add. So put $sign so it will not change. And then remove this one so that when we copy, we can easily change it. Okay, then number 2 criteria. So the criteria is $A criteria range. So $A is to $6 and $A is to so it's $6 is to $A, $25. Basically the range that you are want to add. Then criteria 1, $A is to $A. So basically we need the per floor. And then we already have it. That's it. And then we sum. So we just copy here. So double check. It will change. Okay, so it changed. Then we can check if the total is equal. So we already have the per floor quantity. Now, once you have this one, you can copy this one and put it here. Then make the font black because font black represents that it's the based on takeoff quantity. Okay, so the formula here you need to change because since this is based on the takeoff, you can already check it like this. Formula C. Okay, now so we just need to make it runs. Okay, so at least we have one base. We already have one basis. So for PSQ, it usually happen like this. Okay, we only have one basis. Now, for example, we have okay, so let's settle first this one. Assuming this is a PSQ, so we only have this information. Then we don't have information for the other shear walls. Okay, let's delete this one. Okay. Shear wall 2 and 3. In this case, what we can do, we can just add it, get the ratio from this one. Okay, so simply just get the ratio. Let's put it here. Rebar over concrete, which will be For this case, 9.94. Okay, but it doesn't matter. Okay, we just need the procedure. So 9.94. So we just put here 9.9. Since double check the formula. The formula of rebar here is already based on concrete, so we can just put here the ratio. Just put the ratio here. Okay. Okay. So now we have the quantity for all the structure. So that's how PSQ works. Okay, we just need so for the quantities that based on ratio, we need to make it red. We just maintain the red here. So regardless, so for this one, this is the reference. Then this is the red. This is the red. So no issue regarding that one. So for PSQ, this is how we do it. Now we need to make the summary. Okay. So let's do the summary. Okay, so very important is the method. Now we assume it depends. So sometimes, as I mentioned, foundation can be CIP. Then from the second floor, it will be other, can be already precast. So let's assume it will be something like that. And let's assume that it's for all the structure. Okay. 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 So basically, this is the total. To compute for the total quantity, you can get this one. Copy the last. Then paste it. Make sure to have the gap. So you can tell this one a shear wall total. It automatically change as long as it's okay. Then for the shear wall total, you don't need everything. You don't need this one. Only this. Okay? We will just put the formula again, the sum ifs. Then sum range. So what are we adding? We are adding the concrete. So basically, this is it. 5, J5 up to J38. So we will put again the dollar sign. Then next, once you already have that one, the next is to put the criteria. So what will be the criteria? Just like earlier. So we need first the first floor, the per floor criteria. Okay, so we need the per floor criteria. A, $5 is to $38, something like that. Then condition, $A is to $8. Okay. So since we only need the per floor total, so we can just copy it like this. And then put the formula, double check, and then copy it also out in the next. Now, how to double check if the quantity is okay? So simply just put the filter here, filter the same color or the total. So you just need to make sure that these three will have the same value as the zero total, which is like this. Okay, so everything is fine. Everything is good. So let's double check here. 845.29, 845.29. Okay, so it captures everything. So you can proceed to the next step. Now, in our breakdown, we need to in costing the precast. So basically, for the breakdown and summary, for the breakdown, you can already put this one, the per floor quantity. This will be the per floor quantity. So you don't need to define the thickness for each floor. Okay, so basically just put here, put this one, this will be enough. So then once we do the summary, we need to make the precast quantity per thickness. Need to make it per thickness. So basically, and we also need to generate its kg per square of the ratio reference. So we need to make this one like this. Copy it. Or so sorry. You can copy this one and then paste it here. Okay. In doing this, we can tell that this is PC shear wall. What are the thickness that we have? We don't know yet. Okay. So to know the thickness that we have, uh, assuming there's a plenty of shear wall, we can filter here. Okay, it's very important that the methodology is defined. Okay, you can filter the precast part and then observe. We have 175.2 precast. So we just need two. So define here. Here, let's see. Shear wall 175. Let's do the 175 first, then put the point 175 here. Okay, now we just need, so we only need the precast. So we just put precast here. Okay, for this one, we need to increase the condition. Okay, so since we only need the, we need also the base on precast. That the third, first condition is the per floor. Then the second condition would be the precast items. So let's put the precast items condition. So we have $M, $5 is to $M, $38. Then the condition would be $M is to $M. It should be in precast. So that this condition will ensure us that we will only quantify the precast items. Then the next condition that we want, it should be 175. No? Out of all the precast items, I only want the 175 thick precast. So we should, it's the C, $C, $5 is to $C, $38. Okay? Then what's the condition? It should be $C is to $C. So basically that's all. Then copy. Then you just need to copy the formula up to this point. Okay. Then this is for shear wall 175. You already have that one. Then you can just copy it again to generate for the shear wall 200. So shear wall 200. Okay. Then change this one to 200. Already automatically do it. Okay. Now how to check again? Okay. How to check? So basically you need to filter again. Assuming this too many, there are too many values here. So filter the blue line. Okay. So this is the shear wall total. Then you need to check. You also, if you don't, you're not familiar to the column representation, so you can just open the the blanks. Okay, you can open the blanks. Okay, so in doing that, we now know the name of the column. Now, since it's the shear wall total, then this quantity represents the total precast. Okay, so definitely the total of these two the total precast quantity of shear wall 775 and shear wall 200 should be equal to the total quantity of shear wall. So it's equal 2145.69. So you manage to capture everything. Now, you have the quantity per thickness of precast. The only missing item is the ratio. Okay, so just generate the ratio. You just need to get the rebar here and divide it by the precast quantity. Then that will be a ratio for the 175. Then this will be the ratio for the 200 mm thick. Okay. Sorry, wrong. We picked the wrong value. So this is, okay, it's correct. It's rebar. Then this is rebar. Rebar. Okay. Let's double check the formula. Maybe there's something wrong. Why is it the 0.15 is very small? The 0.75. Okay, that's wrong. So you can see there's something wrong in the formula. So this should be here. Because in doing the ratio, the initial ratio should be based on kg per cubic. Okay, so there's something wrong. Okay, that's why we always need to check how to do the formulas. So that's the, sorry, it's not included. So basically this one. Okay, it should be the kg. We use this one is kg per cubic. Okay, so just put the kg per cubic. So you have the unit. This is the reference ratio for the quantity of rebars. Overall quantity of rebars. Then like that. Now, let's look at this. So it should be very far. It should not be very far. So that's the kg per square. So this will be the kg per square for the 175 mm thick. Okay, this will be the kg per square for the 200 mm thick. Okay, so that's all. That's almost everything that we need to know. You can now do the summary after that. So just put in here the quantities, and it's easier already. I think this part is the one of the major documentation. Okay, now this is in case we are using what do you call this? PSQ. So we only have one sample. Now, assuming this is a DSQ. Okay? It's like sample. This is a DSQ. So we will have another sample. We have, for example, we have shear wall 2. We don't consider it anymore as critical. Or we can consider it as semi-critical. Shear 2. We just increase the the sources, so we have more precise information. Then we can slightly change this one. So we can use change. So just to show that there is changes. Let's delete this one. It's not important. Okay, now we need also the per floor for the shear wall 2. Okay, so to get the per floor of shear wall 2, it will be best to add another reference here. Okay, it will be best to get another reference. Okay, here. You can just put here shear wall 1 or shear wall 2. And put here shear wall 1, for example. Shear wall 2. And shear wall 3. So here, we can change the condition. We can add condition. So we only need shear wall 1. For example, you want shear wall 1 total. Shear wall 1 total. Okay. So if we are using some ifs, so we just need to increase the condition, which is we want only the shear wall 1. So change this one to shear wall 1. Then just copy it here. So we add the condition. Criteria range. So basically we go to the M. It's M. $M, $6 is to $M, $47. So we can change this to 47. Change everything to 47 first. The limit. Then she roll 47. $M is to $M. Oh, this one. Sorry. So dollar is $M. Yeah. Okay, then you can just copy again the formula. Copy again the formula. Okay, then delete this one. This is total. Then we can get the she roll 2. Double check. Okay, so the formula is retained. We can change this one. That's all. So already have quantity for share roll 2. Then we can copy this one to the our reference. Okay. So this is now black because this is based on cutting this. Then we also need to change this formula. We only have share roll 3 or many more. We have 2 bases. So in doing that, we need to improve. So what we can do is to add this one. But this depends on the situation. Like if you have the applicability of the quantity, for example, of the represent uh, sample on selected shear wall. Example, you have shear wall that is only from foundation to fourth floor. Then the ratio should be used only for foundation to fourth floor. It cannot be used going up because it doesn't have structure going up. So that one is a judgment of the estimator. So it's now 11.33. So we put here 11.33. And that's it. So we already have it. Then we don't need to change everything here because there's no geometric changes. Then it already changed. The ratio already changed. Okay, so basically that's it. And once the ESQ come, you will also have the estimate for the shear wall 3. Then you can basically just estimate shear wall 3. And that's it. Estimate shear wall 3. Here. Add it, and then you can finish it. Okay? So as example, this is just a trial. Now we can open the actual. We have an actual. It's an actual raw data generated from one of our projects. That's why I use first the standard template because there's quite changes. They changed the format, the template. There are items that are not present here for checking. Okay, what are those items? First, there should be a total here. Remember? Okay, so this should be this one. Then there should be total here. Sorry, but this might take time because the template has been changed. Not follow. Okay. Then another one here. Quickly to change the formula. Then another one here. Shear wall 3. Okay. Simple. That's good. It's in line. Then double check the formula. Okay. Then shear wall for okay. It's applicable. Then we have shear wall 5. Then this total should be removed with only one. There's no, it's not, it's insignificant. There's something wrong. It's a shortcut. Okay? That's one good thing. They already defined the precast and the CIP item. I'm not just sure if these items, the slab thickness was edited. I'm not pretty sure regarding this one. Oh, mortar thickness doesn't change, so I need to double check this one with the team. Okay. Then, as I mentioned earlier, we just need to copy the last part to do the total shear wall. When you change at the bottom, these things are insignificant. Okay. Then, you can do sa equal sum ifs. So the range is from, it's the first one, 6. 6 up to 242. Some range J $6 to J dollar 242. Okay, then criteria range or A $6 is to $8 242. Then A is to A. Criteria 1 is to get the per floor. Since this total, as I mentioned earlier, you just need one criteria, which is we just want to get the total quantity. And then do it also on the other side. Okay, then double check. Double check the save and then double check. So we need to double check. It will not consume a lot of time. So it's not recommended to do shortcuts. Okay, so let's double check this one. 69, complete. 9865, complete. 2414, basically it captures everything. Okay. Now, for the precast items, so let's filter the precast to see what are the thicknesses. So if you have a lot of, for this case, you only have only 0.2. Oh, we have this. So you simply need to filter everything. So we have a lot of options in filtering. Let's get the precast, check the thickness. So 0.2, 0.25, 0.3. So we need 3 quantities. Okay, as I mentioned again, this total will be the one that will be reflected to the template of BD breakdown of the quantities. Okay, only in the summary it will change, because in the summary the precast quantity should be breakdown. This quantity, specific quantity, should be breakdown into per thickness and shall have per thickness ratio. So I suggest to put it like this. Let's copy this one again, paste it. Let's name this one as 200. So we have shear wall 200. Thickness. Right, well, 200, 250, and 300. So let's put this one shear wall 200. Then we need only the PC quantity that are 200 tick. Okay, then let's put the thickness here. Let's edit the template, the formula. So some ifs, we need the second condition, it should be precast. So $M, $5, and $6 is to $M, $42. Forgot to put some here. Ito one. Then the criteria range should be $M is to $M. Then C. So $C is to 6. $6 is to $C, $242. Then $C is to $C. Okay, what's wrong? Wait, let's double check. $C is to $C. Okay. Just need to copy it. Formula. Then copy here the formula. Okay, then we do the same for 300 tick, and then for the 250, and then for 250, 125, yes, 300, 3, yes. Okay, so again, we need to double check. So remove the filters, and let's return the filter. Let's filter the total only. As I mentioned, the total quantity of these three should be equal to the total quantity in the zero wall total. Okay, let's check. So these three should be 27,897, which is correct. And we already have that's all. It's a breakdown. Now, we go to the quantities for the reverse. Okay, let's go to the reverse. So basically, that's how you derive the precast, how you need to do a breakdown. For this case, I think, let's check what did they do in the takeoff. For the quantity takeoff, okay, we have shear wall 1, shear wall 2, shear wall 1, shear wall 3, shear wall 4, shear wall 5. Okay, in short, they have the takeoff for everything, but the main bar and the ties is separated. Okay, so let's just join it. Okay? So it's not confusing. Also, the colors has been changed. Okay, shear wall 2. Insert cut cells. Let's tag this one as ties and horizontal bars. So we can trace. And then this one is main bars. Okay, so we don't need this tag. Let's make this one yellow and black. Then we put another one at the bottom. And let's make this one black and yellow. Okay, so we need to total this. Something like this. So we already have total. And let's tag this one as shear wall. Sorry. Okay. This is shear wall 2. Now, we go to shear wall 1. Let's change this one as yellow. Black. Let's get its ties. Its ties is somewhere here. Okay, I got the ties and then put it there. Because when we do the estimate, it should be together. It cannot be something like this. It will be very confusing. Then we can take this one as ties, central bars, and then main bars. So we can copy here. One scroll. Copy this one. Yeah, we don't have a choice. We just need to scroll and paste it here. Okay. Then we need share one name and insert it here. Okay. Then do the summary. So this should be black. It's like earlier. This should be black. And this is yellow. Okay. Now we will do it. We'll do the same for share wall 3. Okay. Before we okay. Let's finish first. So we are organized. We can already put the main bar here. And then we get the share wall 3. So this one. So we don't have to go back. Okay, we're scrolling down manually. Okay, now we get the share wall 3. Guys. Share wall 3 times. So this will be times central bar. Then to copy this one, go down, this here. Sorry, turn it black. It's yellow. And then we can just sum. Okay, so that's shear wall 3 quantity. Now shear wall 4. Let's put this one like this. Okay, let's go to the shear wall 4. Shear wall 4. Okay. This is it. Insert here. We have the shear wall 4. This time, so center down. Then copy this one. Should be black, yellow. Okay. Auto sum. This is auto sum. What's it? Shear wall 3 has very high quantity. Oh, because 16 sets, okay. And then we have shear wall 10. So the last shear wall and the last ties. So in doing this, you already have the reinforcement per shear wall. You don't need to do a lot of these color schemes. Let's make it simple. Simple as possible. So it's easier to trace everything. So black and yellow. Then ties or central bar. Okay, so now we have all the conditions set. We don't need these other quantities. What we need now? We need now the per floor. Okay, so let's go to the complete one. Let's find a shear wall that's complete. So maybe shear wall 1 from basement 6 up to top level is this 44. And let's just copy this one. 44. Okay, so space it here. So to get in doing that, there are two ways to do that. Okay? Because of the items are doubled. So we can, but we need to be consistent in naming. So we can get this one. I don't know if they made it consistent. How did they name it? Maybe they make it consistent. But it should be consistent with this one. Okay, so let's paste it here. Maybe we can always double check. Then let's just delete the other items. Okay. So I mentioned earlier, we don't need these items. We don't need these items. Just delete it. We don't need these items. Just delete it. So, okay. So we're looking for shear wall 1. Did we put shear wall 1 on the side? Okay, shear wall 2, shear wall 1, shear wall 3, shear wall 4, shear wall 5. Okay, so since we're looking for shear wall 1, we can just copy here shear wall 1 and paste it here. So we can now put the conditions. Equal sum ifs. So G, need to know the start. Let's start 6. So it's G, G, then 1436. So that's condition 1. It should be $A, $6 is to $A, 1436. It should be per floor. Condition 2, it should be per shear wall. So M is to $M, 1436. M is to $M. So we can just copy this one formula and then copy it here. Okay, then double check if it works. So 01. Check if it works. So how do we check if it works? We can filter. Okay, let's filter here. Let's filter here. Filter color. The yellow one, the black. So you can check shear wall 1 total, shear wall 1. So it's equal. Why is it shear wall 5 doesn't have total? So we can just, also that way you can check who's missing quantity. Okay. So we go to shear wall 1. Share rule 5 doesn't have total. So just put total for share rule 5. Okay. Then we can just copy this one. Upper floor. Share rule 1 total. Share rule 2 total. Let's change this one. Let's check share rule 2. Then we can have. Okay. So share rule 2 is only up to 4th floor. Okay. Then share rule 3. Share rule 3 here. Then we can change this to share rule 3. Then share rule 3 is from transfer floor only. Let's go to share rule 4. And then we will go to share rule 5. Okay. Share rule 5. Let's save this one. Then we have it. Okay. Then we can use this. So since we already have the per floor, then we can just paste it. First double check the quantity. Sorry. So we need to know if it captures everything. It seems it captures everything. So double check 253, something like that. Then so you can just copy the quantity in the bottom, the per floor. Okay, and just put it. For example, 0.5. Just put it here. 0.5. For 0.5. This is 0.5. So you can just put it here. Turn it black. Change the formula. Okay, then 0.4. 0.4. Here. This is 0.4. Put it here. Change the formula. And this one black. Okay, 0.5. 0.3. Same thing. 0.2. 0.3. 0.3. Black. Then just equal. Formula. 0.2. 0.2. So it was cut, so it should be cut like this. Let's change the formula. This one, so we won't have this problem. Keep this one black. Then serial 1. Where's serial 1? Here. Serial 1 is complete. Yeah. Then equate the formula. Simple as this. Okay. So this is all. This is the complete form. You can double check the rebar total. Here. Total rebar 434235. Let's check the total rebar here. You can just filter the black one. And check the total. 1, 2, 3, 4, 5. 2956. So there's something wrong. Okay. Let's double check. Quantity. 500. 300. Plus 13. Plus 13. So there's something wrong. I think this is not something wrong. Serial 1. Maybe I'm wrong in the paste. The one to manage to paste. Serial 1. Right here. Serial 1. Right here. Oh, the formula. Should be paste formula. Okay, so let's check again. Total should be 3330. Total here is 2956. So maybe there's another wrong. 2956. Okay, let's check again. So there you go. Total should be 2956. There you go. 2956. Okay, then we already have this one. Already prepared the precast, so you just need to get the kg per square. So kg per square. Something like that. So we have 58, 140, we have 97. So that will be the total of the precast. Okay, but we can also consider this one, the rate. This precast should be cut length, can be cut length. So just to make it faster, just very small. Let's get the percentage and this one 5%. So basically just 5%. The divisor is wrong. Because we're 5%. Okay. So we can just put 5% here. Or we can just multiply it by 0.95. I mean, times 0.95. Something like that. Okay. So that's how it should be derived. And that's all. We can do the summary based on this one. And I hope everyone will follow the template and use it properly. Okay? Okay, and thank you. That's all.